Well, hello, everybody. Thank you for joining today's Tips and Tricks webinar. Today's topic, as you can see, is on troubleshooting using network traffic. Please use the Q&A chat. If you have any questions during this webinar, we'll make sure we answer those. Our presenter today is an SE from Pennsylvania, Jason Dotre. Jason, what do you have for us today?
Yeah, thanks, Rob. And nice to meet you all here virtually. I'm Jason Dotre, like Rob said, a security engineer here in the Big East. I'm near Hershey, Pennsylvania, the sweetest place on earth. Very exciting. I've been with Checkpoint here for a couple of years. I was a customer back in the 7730 days, and after that did some digital forensics with network disk stuff and some memory items and some incident response. And then I had a chance to join Checkpoint here, so here we are. Again, today we'll be talking, like it says, troubleshooting using network traffic. Is where we're going to start here. It's always good to know where you're doing the troubleshooting, where to start the troubleshooting, because you're going to be, if you've been in IT for a while, you understand that if something's not powered on is quite different than if somebody made a big, huge configuration change. And we're going to look at some of the tools that you use for the network traffic analysis and then how to properly use those in the troubleshooting. But that biggest question that always comes up, again, if you've been in IT, you know that there's no flow chart like this. There is absolutely not a nice troubleshooting button. So you have to come up with questions like, when did it start happening? Did it ever work? Because that'll lead you down a different path. If something was installed and it never worked, is big difference than it's been running fine for 3 years and yesterday it stopped working. What changed? What else isn't working? That kind of thing. Is your data center underwater, for example? So it's good to know where to start. Where are we looking? Which is the second kind of question. If you're familiar with the with this layer 1 through 7, the OSI, it's the Open Systems Interconnected Model. It's a general framework that describes network communication from the physical layer all the way up to the application and back down. If you've never seen this, as your machine or as your application or as your device is getting data, it's hitting your physical and it's going up and down, zipping through these layers really fast. But it depends on where you're doing the troubleshooting. Is it plugged in down a physical layer? Up to, is your application having a problem? Something's wrong with your coding. That's higher up in the chain there. Here's the general idea of it. If you've never seen it, again, we've got your physical hardware up to through Ethernet to the data link layer, up to the fun stuff like the IPs and protocol or IPs and ports and like things like that. And you get higher up even with the firewall rules, protocols, things like that. Then 5, 6, and 7, they get mashed together quite a bit, and we're definitely going to keep them mashed together for this. But it deals with how the data is handed to your application and what it does with it, how it presents it to the application, and what you're actually seeing on your screen or your device, that kind of thing. And again, your data goes up and down really fast, and where you want to start troubleshooting depends on what you're seeing or not seeing. Today, we're going to primarily focus on layer 3 network. We'll do a little bit with layer 2 with the Ethernet side as well, but good to know where we're looking at in this whole crazy OSI stuff. So what tools can we use for this? I mean, there's a lot of them out there, but we're going to focus on a couple today. TCP dump being the big one. If you've done any kind of Linux network stuff in the past, this is everywhere. I mean, you can run TCP dump on any kind of device. It's built into every operating system in Linux. It's very easy to use. It's cross-platform. You'll see it everywhere. But it tends to be a little bit CPU or processor intense when you're ripping through, because it does a little bit of protocol analysis. It'll try to guess, what is this port 22? Okay, what is this 443? Okay, has to be HTTPS, right? It'll do a little bit of analysis that way, but that's where Checkpoint came in with a CPP cap. It's another command line tool. It's on Checkpoint devices from 8040 and up. And in theory, it's supposed to be lighter weight, less CPU impact, so you can run it a little more wild if you want. It's not going to have as big of impact on your system. So if you're running something or doing some diagnostics on a firewall or something that's running pretty hot on the resources, this might be a better choice. But we'll see the differences here coming up. Then you've got FW Monitor, which looks more at the kernel level. So you can only run it on firewalls. It's not on management servers. And this will give you visibility into the kernel and the inspection chain. So you'll see again, we'll get to it, but some inbound, outbound items on different NICs and things like that. And then, of course, we have Wireshark, because you can't talk network stuff without talking Wireshark, right? If you've done any kind of stuff, you've probably run across Wireshark. It's a nice GUI interface. So you can see all the all the data right in front of you. Oh, it's very pretty. You can follow the different streams, things like that. Again, it has a lot of capabilities to it. So you can really dive into what you're seeing in the traffic, and you can look at it at different angles that might help you come to different conclusions based on what you're trying to find. But not what tools can we use, we should also figure out what tools should you use, because what's that phrase again? Not everything's a nail if you're a hammer, something like that, whatever. Great. Wireshark will be able to capture that data, but on your system, but maybe it's not the best thing because it's also doing protocol analyzing and parsing and things like that. It'll really spike your CPU on your running on a server, for example. So if you can run something like a TCP dump, might be better. And if you're looking for traffic on the kernel, something's lost, trying to figure out where is it, FW monitor might be your better option. If you're looking at stuff on physical NICs, TCP dump and CPP cap, fantastic. That's where you're going to want to look. But if it gets into the more, hey, you're missing traffic. I'm trying to find it in the smart console, the firewall. Where is this going? Where is it? This might be another great tool to use. If you're working with TAC on some of the more in-depth investigations or in-depth tickets, they'll be running FW monitor as well as different debugs. So if they might be looking for something going in and out of the kernel, but they'll also be doing a debug on the same thing. This really gets down into the weeds, which is handy. So first one we've got here, TCP dump. This one does require expert mode. Actually, both of these require expert mode, and you can do the output in real time. So if you're just looking, hey, is my traffic hitting this NIC or not? Oh, great, I see it on my terminal. Fantastic. You can also save it and throw it into Wireshark later or for further analysis, that type of thing. A lot of different filters you can use with TCP dump, like BPF or Berkeley packet filters. Pretty slick. But on the checkpoint, when you're running TCP dump -H for help, you're not going to, what you're seeing is not going to be overly helpful, to be honest. It's, it'll tell you kind of what you can do. Personally, and off the record, even though this is being recorded, I might run a man TCP dump from a different Linux distro or different operating system somewhere, because it will give you a lot more information. It'll show you what the different commands or what different switches you can use, and then why you might want to use those. It's very handy. Again, or Google. Stack Overflow always has a ton of people trying to figure out an exact, scalpel type of filter. They're looking for a very specific traffic, and there's a lot of examples out there. Definitely check those out. But some of the more useful options that you have there, why W isn't first, but that's really the first one. You want to write it to a PCAP file for later analysis and later looking. That's kind of the bread and butter there. But with TCP dump, you're also able to use R, so you can read from a PCAP file. So if you want to do some parsing, if you had a huge gig dump of a PCAP, well, you want to look for just a specific host, destination, port, protocol, whatever. You can read from that PCAP, parse it out, and then write it to a different file, kind of carves it down a little bit. Very handy. TCP dump will run against all of your interfaces at once by default, which is not something you want to do, especially on a production firewall, because that's going to be very CPU intensive. So you want to use the -I, which you can specify which interface to capture it on. That gets you a little more targeted there. Then N is going to be a little more controversial. To me, it's very important for OPSEC. If you're capturing traffic and you've got some traffic that's going to, I don't know, say evil.com, you don't want to be resolving that, because every time TCP dump does a capture of it, it tries to resolve the name, and it's going to say, hey, what's this? Evil.com, evil.com. If somebody's watching evil.com, they're going to see your traffic hitting or requesting their stuff. So it's for OPSEC, don't run N. You'll see again, as we start looking at examples here, that N, having a domain name in your TCP dump output, it kind of muddies things up. So I like the N because it cleans it up as well. And you can run -NN. And TCP dump they love all sorts of things like that. So N is going to be resolution for DNS names. NN is going to be resolving protocols. So again, we'll show you in a second here, but if you say, gosh, I would love to see, am I seeing SSH traffic or am I seeing RDP traffic? You could see, hey, this is remote desktop protocol RDP. For the eyes, or when you're looking through it, it's nicer to see 3389 or 22 versus what TCP dump thinks is, what your protocol is there. The last handful there are just going to be for if you're rotating through TCP dump, if you're running an extended capture on something like that and you want to say, just keep this running and keep cycling it over. If you see it, I'll come back to it tomorrow and look at it. Those last ones are going to be for you. And that F is the BPF, the Berkeley packet filters. If you have use those in the past. If you want to load them into a TCP dump, use the F there. Some sample traffic, just because I'm not going to try to generate this in a timely manner. Look at this top one here. Run TCP dump -I to specify ETH2. And then I'm saying, hey, don't resolve the name. So you're not seeing the 888 resolving to Google. It makes it much cleaner. Then I'm specifying my host and ICMP. So it's honestly very, very English friendly. You can put those in quotes if you like. You'll see it in CPP cap. You need that there for the different syntax there. But if you jump down to the second sample there, the SSH, if you'll notice I move the N over, well, it's right after TCP dump there, NNI. So that's I'm not resolving Google, but I'm also not looking at the protocol. So it's .22, you'll see 54.22. So it's SSH traffic. This is a communication between the virtual machine and I'm not even sure what that is, firewall. And it's not resolving it, all that fun stuff. So it's easier to see versus SSH. You just see the numbers. I don't know, maybe it's just my eyes, but for me, that's a lot easier. Do what you want. But you will notice on this one that after the NTCP port 22 on the command, it's actually cut off a little bit. The output, comma, whatever, and it's broken. TCP dump, I had a wider screen when I was capturing that. So if I shrink my terminal down to a smaller screen, it does word wrap. So it's harder to look at. Maybe if you don't have a smaller screen, something you have to pay attention to that, okay, this might not be something that you could just let your eyes rip down because it's going to word wrap, especially when you throw a V in there for verbosity. You're going to start seeing some checksum stuff, your different sequence numbers, things like that. And it's going to word wrap all over the place and, kind of looks like throw up on the screen. Using a -W to write it out somewhere or using a longer terminal is going to be very beneficial. We jump on to CPP cap. Again, with the -H for the help, this is much easier. It shows you exactly what you're looking at. Much easier to use. There's a nice SK there, 141412. It gives you some different examples, some different samples on how to use them. But again, this -H is going to get you in the right direction anyway. And kind of using the same idea with the ping sample here. If you notice, my mistake, wrong button. This -F in our help file is your expression. So here you do have to specify CPP cap with your interface great -F for your filter. It doesn't just, if you throw the filter on there, it's just going to give you a nice error. And again, CPP cap can run against all of your interfaces. Not best practice, but you can. And so here you're going to see, hey, in out on ETH2 for that ping traffic. That's the port on the virtual firewall I had here. But notice that it's only showing you ETH2. So it's going in out, whatever. It's not showing you the other Ethernet port that's actually going out to the internet somewhere. Just something to know when you're specifying, hey, I'm looking at interface ETH2, it's only going to show you ETH2. So if you're not seeing, you're expecting to see it coming from somewhere else, or if you're just something to pay attention to there. And the bottom one, the HTTPS sample stuff. Again, it word wraps, it's handy, it's great, but it gets harder to see. So pay attention to that as well. Again, when you're using using these kind of commands. This one, but you'll notice in the command, it's CPP cap -I ETH2 -D-N, which we look at our switches here was verbose data link layer and verbose network. So you'll notice in this one here, you're seeing MAC addresses, you're seeing some other ether types. It's a lot more information, but you can get more granular with CPP cap saying, I want to see this one specific thing versus a TCP dump where it's give me verbose. And so this might be a little handier on that one. But again, if you check out the SK, it should get you in the right direction. Other one here, FW monitor. Like it says here, it's kernel traffic, it's inspection chain. So you see some post inbound, pre-outbound, things like that. I'll show you what those look like in a second. This is only on your firewalls, though. You can't run this on your management server or your random Linux machine in your back closet there. This is just on your firewalls. The thing to pay attention to here, E versus F for your accelerated, non-accelerated traffic and what kind of filter you might be looking at. Again, we'll show you what that looks like. And FW monitor is nice that you can specify if you have virtual systems on your machine, or on your firewall, you can specifically look for traffic in those. So it's not just Ethernet, it's kernel. Again, this SK here, though, the CPP cap one is fantastic, but this FW monitor one is updated all the time. They're coming out with different ways to manipulate it, ways to make it work better. This is definitely one to keep an eye on. I want to give you a quick traffic flow. I actually borrowed this from Tim Hall. He's a trainer over at Shadow Peak. He does some great classes if you're ever so inclined to jump on those. But just want to show you how the traffic flows from ETH to ETH. Again, we'll just use 0 and 1 for example here. But if we're looking at something off the wire, did something hit ETH 0? TCP dump and CPP cap are going to be your golden nuggets there. You want to know if it actually got there. Do you have a switching, something's wrong upstream, downstream? These are going to get you that traffic. They're going to see the traffic at the Ethernet port running libpcap. It just essentially makes a copy of the packet and just hands it off. Oh, here you go, TCP dump, CPP cap. Yep, one for you, one for you, one for you. Just keeps going. So it's very handy for did this get there or not. When we're talking about the accelerated traffic with using -E and -F, with Secure Excel, it's going to fast track that trusted traffic. So if you have, again, my example earlier of the SSH traffic, my firewall can see, oh yeah, I know this is approved, we're allowed, boom, you're going to see the header go through and everything, but then everything else is going to be zipping over Secure Excel. If you're looking in using -E, you're not going to see it. You're going to see just, oh, here's the sessions set up, no big deal, but you're not going to miss, you're going to miss all the rest of the data there. But then if you're, again, likewise, if you're looking just at -F using for accelerated traffic, you won't see all of it behind if it's slow path. So kind of depends on what you're looking for, something to pay attention to. You can always disable Secure Excel. Don't do that in production. People will not be happy because that's going to take your firewall and send its resources through the roof, because accelerated traffic is, well, it's designed to help your firewall run leaner. When you're looking through the FW monitor logs, you're going to look. Our main example here is going to be I and O and O. So pre-inbound, post-inbound, and pre-outbound, post-outbound. So these I's, but as that SK, I'll show you in a second what that was again, but you also see different things like D's and Q's for QoS and decrypted traffic and encrypted traffic, things like that. It really gets into the weeds. But again, you'll see, like on the left side here, we've got II, and then on the right side, OO. As the traffic is coming up into your kernel and into your kernel, it's a pre-inbound, post-inbound, and then post-outbound, outbound. So you'll see different, depending on where an issue might lie, but that'll help clue you in anyway. Like you might be seeing just a couple I's, but no O's, and that could be something with a routing issue, maybe NAT configurations, things like that to go look for. And again, if you're working with TAC on these kind of things, they'll probably be running an FWCTL debug, looking for different drops, and that should also help clue you in. But again, that's kind of out of the scope of network stuff. But FW monitor, a lot of craziness. So just a quick example of what this looks like. You've got like at the very top, I'm using F looking for secure traffic, but it looks like a lot of craziness on here. Let's kind of break it down. The first part here is your filter check. So if you fat finger and mess up this syntax, which is easy to do unless you've done it a couple of times, this will just error out. It's not going to capture, it's not going to tell you, oh yeah, I'm capturing, and it's not. It's just going to say, nope, hey, try again, buddy. And the syntax for this it looks complicated. It's just source IP, source port, which is 0 for any, destination port, or destination IP, destination port, and then protocol, so 6 being TCP. And if it likes that, it's oh yeah, you're good to go. Then your monitor will start. It'll tell you, hey, yeah, great. We're kicking it off we go. If you're doing, well, then it'll show you the capture data at the bottom here. If you're writing this out to a file, it'll just show you packets underneath that last PPAC there. But again, this SK, that 30583, is definitely something to keep an eye on. I'll just kind of cut out some of the fat here, just to let you see what it looks like here. But again, the command syntax with the F's, it's very simple. And then, and you'll see, well, see if I can get my laser pointer here to do the I's and the I and the O on different Ethernet ports. So it might be coming in ETH4, hits my kernel, all the fun stuff, and goes out on ETH2. Just handy to know. I did a little dump of this earlier, so I saved it off so we can look at it in Wireshark here in a minute. But just using the O, you just slap it on the end and tell it where you want to write off to, and off you go. Maybe it's not best practice to do it in home admin, but hey, it's a lab. Why not? Example using the E filter is a little bit different. So they can't make it too easy. So it's a lowercase e, and then you're going to have to put this in quotes, and you're going to specify hosts and looking for accepted traffic. The output's going to be similar as far as the I's and the O's and things of that nature if you're looking for that. But it will give you this nice warning right in the very middle here. Hey, using the E filter, it's not accelerated. If you want to look for accelerated, make sure you use the -F. And if you're like me, you'll just ignore that part and trying to figure out why you can't find the accelerated traffic and remember, oh yeah, use the F. So, and again, the bottom stuff down here is the exciting part of FW Monitor, seeing the interfaces. So let's cross our fingers and do some demos with Wireshark, right? Because that's more fun that way. Let me pull up Wire. Exactly. What could go wrong in a live demo, right? I did a couple of captures here, and if you've used Wireshark in the past, it might be something interesting, might not be. So by default, you have a default profile here. Wireshark looks like somebody threw up on the screen. It's convenient, but it's not user friendly out of the box. You'll see the number for how many packets it's received, how many packets were captured, your time since the packet capture started. Source destination, again, it's best attempt at protocol analysis. Oh, this is TCP. Good work. All right, 1.1, whatever. Fantastic. It'll give you the length of the packet and some general information that it thinks is useful. And you'll see the different Ethernet options, or Ethernet, some IP, depending on what the protocol is. You'll see that information here. If it's HTTP, you'll see that down there as well. And then on the right side, you'll get the hex for what you're actually seeing. So everything flies across the network running hex, which is terrific. You can, for example, if you see, hey, there's my source IP address, it's going to be, as you click on it, it's going to show up on the right side. Hey, C0881368, that's the IP address. Fantastic. In hex. Well, hex is going to convert that over to binary, and that's what your numbers are. So if you're really looking for fun down this way, hey, enjoy. It's fun to figure out whatever. Might not be useful for traffic analysis. So we're going to look at a different version here. If I throw in this one, again, it's going to look like somebody threw it on the screen, which they did. This is just a PCAP from a honeypot somewhere out there on the internet. But using different profiles, there's HTTP. Again, doing forensics, I kind of had a bunch of different ones, but HTTP is one that I always enjoyed. And if it loads here, there we go. You see, this isn't a huge PCAP, but Wireshark takes an extra second or two to, let me reconvert that stuff. So if you're running this on a live capture, it can start dropping packets because your computer can't keep up that well. But again, I like keeping the number of the packets. There's fantastic. But the bigger thing is knowing, hey, when did this happen? What am I seeing for the time? So they change the timestamps over to the real time it was captured. And the other big thing is throwing source and destination ports in there, not resolving them. So 80. Wireshark could tell me this is HTTP traffic, but I want to know give me the port. I want to know what kind of port I'm looking at here. And then there's a whole slew of other information that you can throw into columns, like servers, user agents, things like that. It just makes it, as you're looking through different traffics. Well, bad example here, but normally you'll see some stuff in there. I'll show you in a second. And then from here, again, it's kind of throw up on the screen, and Wireshark might not be your go-to option for, because you're not going to be recording with Wireshark. You're going to be potentially throwing a PCAP into it, which is the best practice for it. But if you throw it in here and you're going to do some analysis, there's a lot of statistics under here, which are handy. You've got your HTTP, like a request counter. Oops, where it is here, requests. Oops, not going to show me. Wrong screen. Give me one more second, rerun that. Again, gotta love the live demo here. Sequences. Oh, good grief. Come on, pull it down. There we go. It'll show you the different IPs that they're trying to hit, the different, what are they looking for, that kind of stuff. And it can show you, well, all sorts of random fun in here, like your endpoints. This one's going to turn for just a second, but it's not actually endpoint, but it's talking network endpoints. So if you're seeing traffic from, come on, you can do it here. There we go. I want to filter for what's the most. This is the honeypot that was running out there, but what's this 79.110? Okay, it's got a lot of traffic going to it, more than a lot of other things. you're seeing something specific. And if you're doing troubleshooting, you want to get from the Ethernet level, you'll probably know what your upstream, downstream MAC addresses are and what you're looking at. And if something's going to the wrong one, if you didn't find it using a different tool like CPP cap, TCP dump, that type of thing, this will definitely show you, hey, you got a lot of traffic involving these MACs. What's going on? Maybe you have a routing issue, something like that. And from here, if you want to do, more of an investigation, you can, oh, what's this IP address? And you can copy that and go look for it and find out where that's going and all the fun things. The other handy thing on here, if you're looking for, again, specific items, but if I want to look for HTTP requests, HTTP, I already typed it in, so I'm going to cheat, but oh, the request method is get. Well, what are you looking at here? So what kind of get requests did this honeypot see during this time? You're seeing a lot of random stuff. Okay. Well, granted, I'm using this on a little tiny screen for the sake of viewing, but all these different gets. Okay, well, somebody's using a curl. What are they doing? Right click on that. You can follow the HTTP or TCP stream for this. It doesn't really matter. It'll show you the different communications between the client and the server. Once Wireshark gets its button here. Here we go. Okay, great. I've got a host, and here's my user agent curl. So somebody's running a curl against this. Yeah, they could be spoofing that, but whatever. Here's what the server told it. Fantastic. Here's my generic stuff. Nothing fancy. And then it'll still show you what okay, it's going to get the 200. So it was allowed. Fantastic. Just different ways to look at that. This last thing, close this one here, open up the last thing to show you. So using that same profile of HTTP, this is a dump that I took from, that I showed you earlier in the example, the FW monitor. It's, because it's looking at different inspection points, it's kind of quadrupling, at least quadrupling all the different traffic. So it's not going to show you as much with HTTP. But if you set this up, I called it checkpoint because, hey, we're looking at checkpoint stuff. It'll show you this extra item here, CPFW. You can just pick up this information if you went to preferences, and might as well show you, right? Under protocols, Wireshark, and again, this is kind of small, but Wireshark has all these protocols that you could scroll until your heart's content. But there's one FW for firewall. If you didn't put that together, FW1, you want to make sure you enable that. And once you enable that, restart Wireshark, and then this little handy dandy guy here will pop up. And just like anything down here, you can add this, apply as a column, and it will add it to the top up here. And you can manipulate it how you like. You can make it look pretty, whatever. Great. If you just decide under this, gosh, I really want to see the destination port, you can apply as a column. It'll throw it up here too. But this just shows you, again, this is traffic that's actually working. So it's not going to be as exciting, but you're going to see that it came from the 19 network to the 14 network on this lab. It went in ETH4. Okay, great. Pre-inbound, post-inbound, and then it hit Ethernet 2, or hit the kernel. Said, oh yeah, go ahead and send it out. So ETH2 on the way out, and then out. So it just shows you the steps in and out of the kernel there as well. So if you're only seeing, again, if you're only seeing eyes, like where's it, what's being dropped? Do you have a rule set up in place? Is there some implied rule somewhere that's not allowing it through? If you can't find it there, check your NAT stuff, things like that. Check your routing. There could be something there. And then if you really get deep into the weeds, you're going to do some kind of debugging on the kernel itself to find out what's being dropped and where is it being dropped. Whew. All right. Believe, yeah, that's about it. That's all we got. So yeah, in summary, you want to make sure you ask the questions. If somebody's asking you to troubleshooting and what you're trying to figure out, did it ever work? That kind of thing is going to be a lot different avenue than, hey, it stopped working 10 seconds ago. So you got to know where to start, and then use the right tool for the job. Again, you might not need to throw this all into Wireshark. If you're just looking for, is something reaching that certain NIC on my firewall? Hey, just run TCP dump, run CPP cap, and you'll see it either hitting or not hitting. And if it's not, then you can troubleshoot from there. Why is my switch not sending it? Or what's wrong with my router, my gateway, that type of thing. But yeah, use the right tool for the job. And I know we're getting close to the end of the, oh yeah, we're already at 31. Again, my name's Jason. Here's my email address. If anybody, anything you want to follow up with later, feel free to shoot me a message. You want to talk packets? I love that. I love diving into these kind of things. So by all means, you can reach out anytime. Ooh. All right, Rob, back to you. I'm going to grab a drink of water here.
Go grab a drink. You're like an auctioneer there, Jason. Good job. Got some questions for you here. If you run back to Wireshark real quick, I think you showed this in another path, but I just wanted to share it. John said he found very helpful when you find a packet of interest to click on analyze follow to stream on the top menu there. So what I think is
Yep. Yeah, you can follow the stream. You can click up there or you can right click on the packet itself. Yeah.
okay.
Just
Yep. Just wanted to share that.
a bad example of that one, but yeah.
Okay. Somebody asked, do we get a recording of this? Yes, this is recorded, will be posted on the YouTube channel, and the link for that will be in the follow-up email.
Nice.
Let's see. Yeah, we got some more coming in here. John asked, and I don't know if you're going to know this one, Jason. Years ago, there used to be a version of Wireshark specifically made for analyzing checkput output from TCP dump. Whatever happened to that? That
Ooh,
sounds vaguely familiar to me, but I really don't remember that. Jason, do you know anything about that, or any
that
other checkpoint people on the call here?
same with you, Rob. That sounds very familiar to me. I know they used to have something similar to, it, but I know like Wireshark came from, was it Ethereal back, or however you want to say it, way back in the day. But I thought there was a different flavor of some sort that was specifically for checkpoint. It sounded familiar from the 7730 days, but top of my head, I don't know. But it's something I can definitely look up. And
Yeah,
if
we'll
you ask
talk
that
that
question, if you want to
down. Yeah,
shoot
see
me
if
an
we can
email too.
track that down. It does sound familiar though, so
Yeah.
you're not crazy, John. Let's see here. Sorry, analyze, possible capture. Oh, is it possible to take a capture and see exactly what rule is being applied to that traffic? So
Ooh.
can your
Um,
capture look at the policy rule number?
Not that I'm aware of, but it's something to look at. I know FW monitor is only going to show you if it's again on the wire. So it's not
Right.
doing FW monitor itself isn't going to do the diagnostics or isn't going to tell you what rule because it's only looking at is it pre or postbound into the different kernel things. If it doesn't get through, that can lead you to look into a specific rule, but I don't
Yeah,
believe FW monitor.
yeah. I mean, if it's in the policy, we should definitely have a log entry for it, so you can get the rule number from there. But I don't know if you can do it with the packet capture.
I
Again,
know.
somebody please correct me if I'm wrong.
Yeah.
Let's see, other questions. Are you sharing the slides? I think we could share these, right, John? There's Jason. There's nothing.
Who? Yeah, of course. I have no problem with that.
Yep, yep. Uh, oh, somebody said, I guess this is the checkpoint version. This is back when Ethereal Wireshark was updated so often. So maybe that's when they had the checkpoint version.
Yeah.
Um, does all Wireshark come up with the profile checkpoint?
The no, it's something that I had to create. So when you do like here, by default, it just has one called default. When you first install check, Wireshark is going to say, oh, here's a default profile. Great. And you can add, like same with HTTP, with these different silly columns I have on the top. Of course, now it's going to run slow. Once I added these different destination ports and formatted them how I like, you can save the profile, similar with the checkpoint here, because by default, it doesn't, like I showed, it doesn't actually capture the eyes. And of course, this is not the example for that, but if you go down to your preferences, your protocols, down to FW, good grief, a lot of protocols in here. You need to check this one here. And I'm not sure if you can see it too well on the screen here, but the top one saying show firewall one summary in protocol tree. Once you check that and hit OK, you have to restart Wireshark before it actually starts paying attention to it. And then once you do, it'll have it in your frames or your output over here. And then you just need to right click that and then apply as a column. And then it'll drop it up top here. I don't think it actually calls it FW or CPFW. I just, because it just says, here's whatever. You can rename these. You can do whatever you want with them. But once you're in there, then you can, yeah, leave it as a different column. And if you can save the profile, and then you've got your default and you got your checkpoint. And, yeah, whatever other ones you out there. But yep.
Yep, great. Let me see. Is there a way to share the profiles files?
Yeah, you can do. I'm not sure if I could probably figure out how to, yeah, because I've changed them between different machines instead of recreating every time because that
Right.
gets hairy. So yeah, you can definitely you export the profile. I'd have to remember exactly where that is here. But yeah, you can export it, and if it's something that they actually want, I can get you a copy of that too. If yeah, I don't have a problem with that. There's nothing proprietary in it.
Okay. Well, John who asked the the Wireshark checkpoint question. Says he thinks he found it here.
Nice.
Ethereal for checkpoint, CSP community.
Oh,
So I guess it is out there. So thank you, John. We'll go check that out. Does Ethernet still have the FW-1 monitor option? Doesn't Ethernet still have the Firewall 1 monitor option?
does Ethernet have it?
I'm not following that one.
I'm not sure either, actually.
Hey, John, we should have you on one of these. He said,
Let's see.
he's digging in on that checkpoint Wireshark. He said it actually decodes the output from FW monitor.
Yeah.
So sounds like something to check out. Thank you for that, John. We will check that out.
Because this one doesn't have any, typically it won't have Ethernet information in it, but it's,
Right.
Yeah.
All right. I think we covered it. Some questions came in fast and furious there, so I apologize if I missed something.
and really, if you guys feel free to grab my email address there too, if something comes up that you think of later on, I could share the slides too, but if somebody says, hey, I got a quick question, feel free to shoot it over and I can always do my best to help out.
Absolutely. If we don't have the answer, we'll find it for you. So thank you, Jason. Great information. We will send out that follow-up email I said with the reference content, the SK article Jason mentioned, and the recording link. That'll be up on our YouTube channel. Next webinar will be in 2 weeks. You will see the invitation for that soon. But thanks again for joining. We'll see you here next time. Thank you, Jason. Everyone,
Thanks, Rob.
enjoy your day.
Thanks for joining, everybody.
See ya.